Hey, 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 and welcome to your first lecture in Anatomy 202. This lecture is on the endocrine system and designed to help you for exam 1. Before we start, let me give you some tips. First, have your notes printed out just like you were sitting in class. Sit somewhere that there's no distractions. Turn the TV off. I have to put my cell phone away because I like to play on my cell phone too much. So put your cell phone away. Don't try to email or watch TV or, eat supper, whatever. Have your spouse be on daddy duty or mommy duty, and you focus on this video. So have your notes printed, and what I would do, this is just my personal opinion, I would have my notes printed, but I would also have a highlighter and index cards. And I would actually make my index cards for studying while I watch the video. So every slide, I would pause the slide and write on my index card and highlight on my index card what I say to do, what the teacher says on the video to highlight, because I'm going to tell you what to highlight. So I would listen to it, make my card, and then mash play. Pause. Listen to the video on that slide. Make my card, highlight, and then press play. So it may take you twice as long to watch the video. However, your cards are made and you've highlighted appropriately. That's just my advice. That's my tip. But you do what works best for you. I know that I want you to make an A. I want you to understand this material so well that you can make 100 on the test. So let's go ahead and get started. The endocrine system you're going to love it. You really are. It's so interesting to see how your body can communicate. And that's what it's all about, is communication. So maybe write that in somewhere. It's on some slides later, but I wrote it on the other side. But how your body can communicate with your body. And so let me give you an example. Females, we have a brain. Oh, we have a brain. Yeah, we do. Now we have a gland in our brain called the pituitary gland. Not pictured for some reason. Oh, yeah, it is right there. My bad. Okay. So it is pictured. But what it does is it communicates with just one example of what it does, ovaries, to tell us when to ovulate. How cool is that? And your body communicates, just another example, and you'll have to know these examples right now. The thyroid gland right here in the throat. It communicates with our digestive system to speed up and slow down metabolism. And so your body is this amazing system. It's saying, okay, start, now stop, start, stop. And that's how we regulate our body's processes. Now, how does it communicate? What does it communicate with? It communicates with hormones. So hormones is the language, we'll say. Okay, so just some general characteristics of the endocrine system. First, ENDO means inside, right? And then EXO means outside. So there's two types of glands. Glands release hormones. Okay, the endocrine glands, they release hormones into the bloodstream. So highlight that. That's the big idea here. The endocrine glands release hormones into the blood. And then the hormone, remember that's the message, travels through the blood to a specific target cell. Right? And you always want to highlight what I highlight because that means it's important. Okay, so the endocrine gland, for example, the pituitary gland, releases a hormone, a chemical messenger, that travels through the blood and tells for our other example, ovaries, it's time to ovulate. And then in that story, the ovary is the target cell. So it travels to the target cell. The exocrine gland, so both are considered endocrine system, they glands that secrete into ducts or tubes like sweat glands, and they go external, right? EXO means outside, so externally. There are also some glands that secrete messenger molecules, including, paracrine. Para means near. So the hormone doesn't go into the blood, it just travels and communicates with nearby cells. So cells that are nearby. So like your liver cell communicates with your liver cell. Autocrine secretions, which affect cells that secrete substances. So those are just some other examples, but that's a big idea of the endocrine system. Now here's a picture that goes over what I just went over. You've got exocrine gland, they're ductless. They travel into the blood through the target cell to the target cell. Exocrine lead to body surfaces like sweat and oil. I think what you see there is a sweat gland. Paracrine are going to be local, so highlight that word. Paracrine are local. I didn't think that was on the last slide. Paracrine are local, and autocrine affect only secreting cells themselves. So it's kind of like AUTO. They talk to themselves. Self. Right? Like auto body. You go and you buy the part and then you fix it yourself. Auto parts, whatever. AutoZone. Okay. You'll remember from 201, the last thing you talked about was the nervous system. And nervous system is also communication. So on the bonus assignment, that's the first question. What is the compare and contrast the nervous system and the endocrine system? They both communicate. That's the compare part. They both communicate, but they communicate differently. The nervous system communicates with neurotransmitters that are released from the brain. Remember, it goes down the little dendrite. I got a picture here. Remember, the nervous system, looking at this here, it sends the neurotransmitter down the dendrites, down the axons. Ooh, that was bad. So these are axons, those are dendrites, and that's not on the test at all. Anyway, but you do want to know the nervous system transmits, the word that to highlight is neurotransmitters. The endocrine system is going to be, if you go back a slide, is going to be hormones into the bloodstream. So you want to know both of these bullets right here. Highlight both of these things. Right? So nervous system is neurotransmitters. Endocrine system is going to be hormones in the blood. But they're both communication. Both systems communicate with chemicals. They're just different types of chemicals. The endocrine system, it tells you on the bottom of this slide, is precise. The thyroid controls metabolism. It's very specific. It's precise and specific in that only target cells can respond to a specific hormone. Now, the target cell, that's what it acts on. So, the gland releases a hormone that acts on a specific target cell. So, it contains particular receptors for the hormones. These receptors are not present on their cells. So, it's almost like it releases a puzzle piece. And this is not scientific, but think about it this way. The gland releases a puzzle piece. And that puzzle piece can only fit onto its matching cell. So when the pituitary gland in your brain communicates with your ovaries, why doesn't it communicate with the cells in between your brain and your ovaries? Because you know it passes a lot of them. It's almost like it's magnetic to the perfect target cell. It's the coolest thing ever. Okay, there's your major glands. And in this PowerPoint, this PowerPoint consists of details about each of these glands, what hormones they release, and what do those hormones do. So take a second, pause this, and just get a visual idea of, where's the hypothalamus? That's in the brain. Pituitary gland is right below the hypothalamus. Pineal, also in the brain. The thyroid looks like a little bow tie in the neck, right? Like to see the bow tie. The parathyroid is P-A-R-A, around the thyroid, parathyroid. Adrenal glands are on top of your kidneys. The pancreas is in between the two kidneys. It's not really in between, it's kind of in front of them, but in the picture it looks like it's between them. And then ovaries or testes, of course you have one or the other. Ovaries, females, testes, males. But you probably didn't have to come to college to learn that, right? Okay, so take a second and just look at this. And this will maybe help you with a lab too, knowing where everything is. And here it is in a nice table. You'll want to come back and look at this table at the end, because I'm about to talk about all these things, and it doesn't mean anything yet, now does it? And so the hypothalamus, it'll tell you that's what it releases. The pituitary gland, front and back, anterior and posterior, that's what it releases. And so this is just a summary, really, of the whole system in one table. Okay, so hormone action. Hormones are secreted. They're released into extracellular spaces around the endocrine cells. They go into we've already highlighted it a few times, they go into the bloodstream, right? So they go through the bloodstream onto a target cell. And there's 3 steps to this process. So the cell signaling, or signal transduction, is what I learned it as. There's 3 steps in receiving the chemical message, right? So I'm going to draw this out for you too. Okay, so here's your target cell. Here's your hormone. Okay, so your hormone is going to bind to the target cell, right? So it's going to attach right there. And that's step 1, reception. The signal molecule, that's hormone. The signal molecule, that's the communicator molecule, attaches to the cell. Okay, now transduction. The signal is translated. It changes. It is, if you speak 2 different languages, like it's English to Spanish, it's translated by the cell. And secondary messengers may be used here. We'll go over some details of that. And then the cell is going to eventually respond. So back to the initial example that I gave, the hormone that says, right, signal molecule, to ovulate is released from the brain, goes through the blood, and it binds right here. And that's reception. Now, it doesn't go inside because it's a hormone that's a protein. The proteins don't go inside. Steroids do, but I'll go over that in a second. The protein hormone binds, and then it's translated. That's step 2. It doesn't go inside, but it's translated. Then the cell, what does it do? It ovulates. It responds. So it does what it's supposed to do. Now, what kind of hormones are there? There's steroid and there's not steroid. If I wrote the book or I got to write the description, I'd say there's steroid and then there's protein. I don't know why it's not steroid. So there's steroid hormones, and they can actually go through the cell membrane. So they don't bind to the outside like the image I just drew. They go through, they diffuse through. So steroids and thyroid hormones have poor water solubility. Steroid hormones can diffuse through the lipid bilayer. So they can go all the way through, and I'm going to show you some pictures. An example would be testosterone. And the other ones, but you want to highlight what I highlighted. Testosterone and estrogen, and then adrenal cortex hormones like cortisol and aldosterone, which will mean more when we talk about those. The non-steroid hormones are protein hormones. So non-steroid hormones are, right in maybe, they're all protein hormones. So all of these things, all of amines, proteins, peptides, and glycoproteins, all of those are kind of like proteins. Proteins are made up of amino acids. That's proteins. Peptides are proteins, and these are proteins with sugars attached. So most hormones are protein hormones, not steroids. And so this table will show you an example of some of each. And again, those examples will mean more once we talk about them. Okay, so this picture is showing you, this is your cell right here. So that's your cell membrane. And this is your hormone. Now, that hormone, if you'll look, let's change colors here. That hormone goes through the cell membrane inside. And so that would be a steroid hormone. What was the example of a steroid hormone? Testosterone. Okay, this picture is different. There shows, Okay, here you'll see this little purple hormone right there. Oops. That would be a protein hormone. And when it binds, it doesn't go through. Because protein hormones, or non-steroid hormones, they don't go through. And so those pictures will kind of help you. I do want to point some things out that you want to make sure and put on maybe an index card. And how I would do it, I'd put this on the front of the index card, and then on the back I'd write stuff. I wouldn't write all that, but I'd write stuff. Okay, so protein hormone, it binds to the cell membrane. It doesn't enter. Or non-steroid hormone is a protein hormone. Now, I want you to point this out. CAMP. That's a secondary messenger. You probably heard of before ATP. It's energy. And that stands for adenosine triphosphate. Okay, well, there's 3 of them, right? 3 phosphates. Well, AMP is adenosine mono 1-phosphate. So it's just a form of broken down energy, right? But CAMP is needed to activate the protein kinase. So write that in on this slide or on this card. CAMP is needed to activate protein kinase. Okay, and then also make sure you know that the non-steroids are proteins, and they don't cross. They don't cross the cell membrane. Steroid, hopefully you saw this in this picture. Steroid hormones, and maybe write it in if you didn't. Steroids cross the cell membrane. Good. But let's just talk about some abusing hormones. When you think of hormones, until the endocrine system, I think, lecture, you probably thought of anabolic steroids or illegal steroids. But let's kind of touch 3 things. So this is abusing hormones for athletic performance, and the first one would be steroids, and that's what we consider anabolic steroids. That's they're used to make athletes stronger and faster, and what they do is they make you work out. They allow the athlete to work out longer and harder. However, it's a testosterone. And first they make you angry, enraged, but if you increase your steroid intake, then eventually your body's going to stop making those steroids. And so it can be harmful, and that's why they're illegal, but they're used to increase muscular strength, can have many harmful effects, such as you won't make testosterone anymore after an extended period of using them. They can shorten your growth. They can increase breast development in males, so they can have male sexual characteristics in females, so females can actually start to get facial hair and deeper voices, and even some that are worse than that. They're bad for your kidneys, bad for your heart, so lots of problems with them. Okay, growth hormone is also used to enlarge muscles. Now, growth hormone can be prescribed by a physician to help you grow. Totally different. This is going to be illegal ones we're talking about, used instead of or with steroids. And erythropoietin, that was, I think, now I might be wrong, y'all Google it when you get a chance, but I think that's what the bicycler was using, Armstrong, right? Used to increase the number of red blood cells and oxygen delivery to the muscles. And so what it does is erythropoietin is a hormone that your body makes, and it increases it. Your body naturally makes it to regulate your red blood cells. Well, he was taking it to increase the amount of oxygen. Red blood cells carry oxygen, so that he could ride his bicycle longer. Anyway, so those are just 3 clinical applications I wanted to mention. Now, negative feedback, huge topic. This is big stuff, important for your body, not necessarily for the class, but it's important there too. But negative feedback is how your body, okay, so thinking it starts a process, stops a process, starts a process. So it balances it right on medium, right? So negative feedback is, we control homeostasis with negative feedback. And I know you've heard of that before. We control homeostasis with negative feedback. Example, blood sugar. Or no, let me give you an example of body temperature because it's a little bit easier to understand. When you get hot, what happens? You sweat. And the sweat lowers your body temperature back to normal. When you get cold, you shiver. And that increases your body temperature back to normal. So negative feedback is maintaining that normal level. It might rise or be lowered a little bit, up, down, up, down, up, down. But for the most part, it's going to maintain that normal temperature or normal blood pH or normal blood sugar. So for all the levels in your body, there's a perfect level, a range, perfect range, and you want to stay on that perfect range. So negative feedback, a control mechanism in which rising levels of hormones leads to a decrease. So up, down, up, down, up, down. So they're regulated. And this picture will show you how just up, down, basically maintaining it. And this is just a general for hormones. So hormones are too high, then too low, then too high, then too low. And it is a stimulus. So thinking about body temperature, when you get hot, that's what stimulates sweat. Sweat is the response to get you back to normal. And so there's a stimulus involved and a response to keep you on normal. Okay, prostaglandins. We mentioned those at the beginning of the video, or at the beginning of the lecture, and they act local, right? So we highlighted already locally. If you want to write it in again, do so. They act locally. Okay, highlight, regulate cellular response to hormones. So they regulate cellular response to hormones. They only act on their neighboring cells, so the cells nearby. Just an example that I have of this is liver cells. When they are infected, like with hepatitis or something like that, the liver cells will release a hormone, or release a signal. Hormones really go into the blood. They'll release a signal that tells the neighboring liver cells, hey, I'm infected, I'm sick, I've got a virus, you need to be aware that there's a virus. So they can activate or inhibit that adenylate cyclase, the CAMP production. Alright, now we're into the meat and potatoes. That's the picture similar to the first one, where the glands are, and we're going to talk about each one of them. Okay, the pituitary gland is first. Now, in your brain, there is an area, and I'm going to highlight it for you in purple, let's say. This area up here, that's the hypothalamus. And that's not very good, is it? The hypothalamus, so it's like right in there. The hypothalamus controls the pituitary gland. So, actually look down here at this picture. You'll see the hypothalamus is right there. So it's like right in there. And it kind of to me, it kind of looks like a bird. Do y'all see the bird? There's like the eye of the bird, and then there's the beak of the bird. I know I'm crazy. Okay, so the hypothalamus is this area right here, and you might remember that from 201. But it controls the pituitary gland, which is right there. And that's what we're talking about. Well, there's two parts to the pituitary gland. It looks like it's like hump. That's what the pituitary gland looks like. And this is the front of the face. So there's your nose and eyes and all. There's your hair. Pituitary gland is a little inside there. Anyway. Ooh, that's not a very good drawing. Now, the pituitary gland has a front, anterior, and a back, and they do different things. So there's a front, which means anterior pituitary gland, and then the posterior pituitary gland. they're actually even controlled differently. So hormones control the anterior part. The hormones from the hypothalamus control the anterior. And it's going to be glandular epithelium. The posterior part is actually controlled by nerves. So the posterior, look at the picture, is controlled by nerves. The anterior is controlled by hormones from the hypothalamus. So you want to write that in or highlight it on there. I have written nerve impulse from hypothalamus control the anterior pituitary. Hypothalamus hormones control anterior. Nerves from the hypothalamus control the posterior. So somehow I need you to remember that. Anterior is going to be hypothalamus hormones. The posterior is going to be hypothalamus nerves. Right? So make sure you remember that. Okay, and I'm telling you, this is the most complex set. So the hypothalamus and the pituitary gland. After that, it's easy breezy. Okay, so what does the anterior release? There we go. Anterior, that's the front, the first little hump, releases all those hormones. I'm telling you, it's the hardest one. If we can get through this, you're good to go. But this is the most interesting part. Okay, so each anterior lobe hormone is released in response to hormones from the hypothalamus. Now, what does it release? Growth hormone? Come on, it doesn't take a scientist to figure out that makes you grow, right? Bones grow. Long bones grow. So the brain tells the muscles and bones and cells when to divide. Prolact, L-A-C-T, milk. This could be released in males or females, right? But it only is released in females after birth, and it makes the milk come in, so in the breast. So it makes promotes milk production in females. Okay, guess what this one does? It stimulates the thyroid to work. And we'll learn later that the thyroid does metabolism. But for now, just know the anterior pituitary gland releases a hormone called thyroid stimulating hormone that stimulates the thyroid. Okay, adrenal corticotropic hormone, adrenal gland, corti, outside, tropic. That's a tropic is a hormone that tells another hormone to be released. So adrenal corti, the outside of the adrenal gland, corti means covering, the outside of the adrenal gland hormone is stimulated. So I don't know why it's not called adrenal cortex stimulating hormone. But that's what it is. It stimulates the cortex of the adrenal gland. Okay, follic stimulating hormone. That's going to be what stimulates sperm cell and egg cells to be made. If you're a girl, egg, boy, sperm. So sperm cells, egg cells, and then it also tells the eggs to get ready. And then luteinizing hormone that's ovulate. So this is going to be egg and sperm. And this is on another slide. I don't know why I'm writing it. And this is going to be ovulate. It's showtime. Drop the egg so maybe we can make a baby. But it causes sex hormone, estrogen, and testosterone in both female and male. Okay, pictures are worth 1,000 words. So this picture is worth a lot of words. Okay, looking right here. Your hypothalamus, look closely at it. The hypothalamus releases these. Okay, and then, so growth hormone releasing hormone, somatostatin, and they both tell the anterior pituitary to release growth hormone. So these are from the anterior pituitary. These are from the hypothalamus. Okay. Prolactin releasing factor, prolactin inhibitor. Control, okay, make prolactin. Don't make prolactin, make prolactin. Prolactin, remember, stimulates the breast to make. So it shows you stimulates the breast to make milk. Growth hormone stimulates the bones and muscles and fat to grow. So the hypothalamus releases, so let's go into the next one. The hypothalamus releases thyroid releasing hormone, which stimulates the anterior pituitary to release thyroid stimulating hormone, to the thyroid. Okay, so you can kind of see how the hormones of the hypothalamus control the pituitary, the anterior pituitary gland, and it controls all of this. So now you'll see why the pituitary gland and the hypothalamus working together. That's the most. Look at all it controls. It's Big Mama. It controls a lot that goes on in your body. Okay, so here's a list of those anterior pituitary glands, and I went over them when they were listed, but here's a description of each. One more? Yeah. Okay, so growth, and there's a lot you want to highlight on this, so you actually want to know what they each do. So I'd probably make a card for each one of these. So you hopefully made a card that said anterior pituitary, and then you listed the hormones. Now these, you listed them, so I might ask you a multiple choice question that says, which of the following is not released by the pituitary gland? A, growth hormone, B, prolactin, C, thyroid stimulating, or D, insulin. And the insulin's from another gland. So make sure you know them, but then you also want to know what each of them does. So you're going to have a card that says growth hormone. And then you're going to write this on the back. Stimulates cells to enlarge and divide rapidly. And you want to write in on that card bone cells. Long bones. Okay. Prolactin, that's going to be milk. Thyroid stimulating hormone stimulates the thyroid. And we'll talk about what T3 and T4 are later. Okay. Adrenal corticotropic hormone is the hormone that stimulates the cortex of the adrenal gland. Okay. Follic stimulating hormone. So you want to write in right here. This is going to be sperm and egg cells. Oh, it says it. Egg production, sperm production in males. So it causes growth and development of the follicles. That's going to become the egg. And then luteinizing hormone is going to be actually what makes you ovulate. Okay, and for the follic stimulating hormone, and write in sperm cells, egg cells. So because I read it in. Sperm cells, egg cells, and follicular cells to make estrogen. One thing I want to mention, a lot of times these are abbreviated. So growth hormone would be GH. Maybe PL, thyroid stimulating hormone, adrenal corticotropic hormone, follic stimulating hormone, and luteinizing hormone. So, just wanted to mention that. So this is 3 deformities from the growth hormone. Either you have too much or you have not enough. And so growth hormones ups and downs. So the first one is hypo. Remember that hypo, H-Y-P-O, means below. Hyper, H-Y-P-E-R, means above, which is not on the slide. But hypo, below, would be a deficiency of growth hormone. So highlight that. You have less growth hormone. Giganticism, that's going to be too much. Right? Growth hormone makes you grow. So you got less hypopituitary dwarfism. It's really dwarf. So focus on the word dwarfism there. Too much. You grew too much. Okay. Acromegaly is caused by oversecretion of growth hormone during adulthood. So this one was during childhood. Okay, so that was all the anterior. So all those hormones, growth hormone, prolactin, follic stimulating, luteinizing, all those were anterior. Now we're on to the posterior, and it only releases 2. See, I told you if you could just get through that first one. There's only 2. The first one is antidiuretic hormone. Second one is oxytocin. Okay, super interesting, both of them are. The first one, the back, we already said, has nerve fibers, right? not hormones, but nerve fibers of the hypothalamus. Now, ADH, anti-diuretic hormone, what it does is it tells your kidneys to store water. Okay? Don't TT, store it. Hold the water in. So it says it decreases urine production. So you want to know all this. Decreases urine production by reducing the volume of water in the kidneys. They secrete. So tell the kidneys to store water. So think about this like magic fairy dust. You got this ADH that comes from the brain that sprinkles on the kidneys and says, hold on to the water. Decrease urine production by reducing the volume of water that the kidneys release. So hold on to the water. Also causes vasoconstriction to increase blood pressure. So it's pretty important. Increase or decrease blood pressure. Okay, ADH, think about when would you release ADH more? When you're sweating a whole lot. You're losing water out of your skin. So your kidneys are like, whoa, hold on to it. Don't store it. When you're dehydrated, you're going to release lots of ADH so that you store more water because you want to keep your water level on normal, on homeostasis. So, you're sweating a lot, you're dehydrated, whatever, you're going to release a lot of ADH. Now, let me tell you something interesting, which is not on the test. When you consume alcoholic beverages of age responsibly, right? Okay, when you start to consume alcoholic beverages, your body senses that there's a toxin in the blood. Second it hits the bloodstream, your brain senses that there's a toxin in the blood. So your body stops releasing ADH. Don't store the water. It's got a toxin in it. Flush it out. And that's one reason why when you're consuming alcohol, you have to TT a whole lot. So you have to TT to get the toxin out. So while you're drinking alcohol, you'll notice, because you're drinking beverages too, you have to TT a lot. Okay, oxytocin, second one, from the posterior pituitary hormone gland, is going to be what makes the uterus contract, flex. Now, this is all of that we've talked about so far is negative feedback. If you need more, you make more. Once you make too much, you make less. Oxytocin is an example of positive feedback. What that means is when you release oxytocin, you don't stop releasing oxytocin to regulate. No, that's negative feedback. Positive feedback is where when you release oxytocin, then it causes your body to release more oxytocin. More oxytocin. So it stimulates. Positive feedback will say stimulates more. So where negative feedback is a regulator, positive feedback is a stimulator. Okay, and here is that's the pituitary gland in a table. So you'll see these are the glands. So look over this. These are the glands of the anterior. These are the hormones of the anterior. These are the hormones of the posterior. All right, next one, and we're going to start flying through them. You're going to be loving them from now on. That was the hardest ones. The thyroid is in your throat, just below the larynx. It looks like a bow tie. So it's in the location of a bow tie. You'll notice when you study the lab pages, the lab pictures where everything is too. So the thyroid is below the larynx or voice box, anterior to the trachea. That's your windpipe. Has special ability to highlight the word iodine. Okay, the thyroid, that's not a highlighter now, is it? There we go. The thyroid the follicular cells, which we're going to talk about, the follicular cells require iodine. And so it has a special ability to remove iodine from the blood. But your thyroid releases 3 hormones: T4, T3, and calcitonin. Okay, T4 and T3 both control metabolism. So maybe write the word right there, metabolism. Right, and you know what metabolism is. That's your ability to break down food so you don't get too fat, or or maybe you break down food too fast so you can't gain weight. That's not my problem. Anyway, so metabolism, T3 and T4 metabolism, and then calcitonin. So You want to know the thyroid releases 3 hormones, T4 and T3, which both control metabolism, and calcitonin. Now, the follicular cells, if you look at the picture, you'll see the follicular cells are on the outside. They require iodine. Write that in. Follicular cells require iodine. But they produce the T3 and T4. The extra or parafollicular cells, that's these, they release the calcitonin. Now, what do? T3 and T4, we know, are metabolism, right? Metabolism. Calcitonin lowers blood calcium. So that's what you want to know. Calcitonin, it stimulates, let's write it in. Calcitonin stimulates so this is calcitonin. The rate that calcium, Ca+, is deposited in bone. And you also want to know that it lowers blood calcium and phosphate. So maybe I'm visual. So, but right here beside calcitonin, you want to write in lowers calcium. Good. Okay, here's the disorders of the thyroid. And so we hear people that have thyroid cancer and hyperthyroid, hypothyroid. That's, remember, hyper, Hyper, means above. So that's just not really for this class, but for everything. Hyper means above. Hypo means below, right? Okay, so hyperthyroidism, you got 2. Hyperthyroidism and Graves' disease. And we're going to talk about Graves' disease specifically. Okay, and then hypothyroidism, there's 4 listed. Okay, but let's zoom in a little bit and talk about Graves' disease specifically. Okay, Graves' disease is a hyperthyroidism. So it's when your thyroid is overworking. Metabolism is high. Okay, you got a high metabolism. Let's see, does it say that anywhere? Hereditary is autoimmune. That means your immune system is attacking your thyroid. Okay, so you have high levels of thyroid. But here you go, write this in. High metabolism. Weight loss. And enlarged, there it is, enlarged thyroid. There was weight loss too. Good. And here's a picture you can see. So you want to know about Graves' disease and that it's hyperthyroidism. And then you want to know what I just wrote in on that last slide. Okay, and you also want to know that cretinism is babies, infants. Hypo, but it's only in babies. And with cretinism, write in for me, stunted growth. Oh. And mental retardation. So stunted physical and mental growth. Good. Okay, parathyroid. Just think about you got your bow tie on. Well, on your bow tie, there's 4 little polka dots on the bow tie. The bow tie was the thyroid, right? So the parathyroid are little bitty glands around the thyroid. So they're posterior surface of the thyroid gland. There are usually 4. And look, this is easy. Parathyroid gland releases one hormone called parathyroid hormone. Woo! Easy, good stuff, right? Parathyroid gland releases parathyroid hormone. What does it do? It increases blood calcium. Remember, calcitonin decreased. So, increases blood calcium. Okay, parathyroid, posterior surface of the thyroid. So, you'll see them right there, the little polka dots. 4, usually, parathyroid hormone. Now, what does it do? Highlight, know it, increase levels of blood calcium. Where does it act? What does it do? It acts on the bones, kidneys, and intestines. Okay, think about this. If it puts calcium into the blood. So it's going to take calcium out of the bones, kidneys, and intestines. So, when the blood calcium is low, that's the stimulus. When it's low, parathyroid hormone stimulates osteoclast. That means break down bone. Clast means break. So, stimulates for the bone to break down and inhibits the bone to build up. So, maybe just a little side note, the suffix clast is breakdown. So osteoclast is to break down. Osteoblast, B-L-A-S-T. Can you tell that's a C? Is to make bone. Build bone. Okay, so what does it do to the bone? You want to know all this. To the bone, it stimulates to break down because when blood levels are low, parathyroid is going to say, okay, take calcium from the bone, put it in the blood, because it increases levels of blood calcium. Okay, parathyroid increases the calcium retention and activates vitamin D in the intestines, so intestines absorb more calcium from the food. Okay, and then intestines absorb, so kidneys, parathyroid, increased calcium ion retention, storage, and then the intestines. So it acts on all three of those. Next, adrenal glands. They sit on top of your kidneys, and the textbook says this, not me. It sits on there like a party hat. It just says a cap. The gland sits like a cap on each kidney. So you have adrenal glands sitting on your kidneys, right? Okay. Okay, party hats sitting on your kidneys. There's two parts. There's the cortex, or the outer portion. Then there's the medulla, which is the middle or the central portion. Okay, so basically it's kind of like two glands. You got an outside and an inside. Pituitary gland, you had a front and a back. Adrenal gland, you have outside cortex, inside medulla. Okay, there we go. What do the hormones do? So this is just medulla right here, this slide is. Okay, there's epinephrine and norepinephrine, and you've heard of those, like adrenaline. It always makes me think of Legally Blonde when she says about the trial killing her husband, and, exercise releases endorphins. That's epinephrine and norepinephrine together are considered your endorphins. And, happy people, because these are your happy hormones, happy people just don't kill their husbands. So, anyway, that's a side note. Okay, so epinephrine and norepinephrine are both released from the medulla, right? So this is the medulla. Epinephrine and norepinephrine. Now, what do? They work together. They increase heart rate. You almost have a wreck, boom, and your heart rate speeds up really fast. That's why epinephrine and norepinephrine release. These are steroid hormones, and they have a fast reaction. force of contraction increase. So they make your blood speed up, your heart speed up. Okay, vasodilation, epinephrine makes your blood vessels dilate, open up. Where norepinephrine makes your blood vessels constrict. It'll make your airways close up so you can't breathe as good. It's going to increase metabolism. When your heart rate speeds up, you're digesting those hamburgers faster. And that just tells you it's 80% epinephrine and 20% norepinephrine. Okay, that covering, it does like 30 steroids. But don't worry, we're only going to focus on 3. 3 important ones are aldosterone, cortisol, and adrenal androgens. Okay, aldosterone, think about water levels. Helps regulate the concentration of those electrolytes, those body salts. Okay, let me break that down for you. It's blood pressure. It helps control the blood pressure. And so, too much sodium, not enough sodium, things like that. Cortisol is going to decrease the breakdown of proteins and increase fatty acid release. So, again, it's blood pressure. Decrease the protein breakdown, increase fatty acid release. Okay, for cortisol, highlight this. Decrease protein synthesis. Oh, man. There we go. Decrease protein synthesis. You want to know that. Aldosterone, blood volume. So maybe it doesn't say that, so let's write it in. Aldosterone. Controls blood volume. And pressure. With those electrolytes, sodium and water. Good. Okay. And then the other one, which we haven't mentioned yet, is adrenal androgens. Okay. The word androgen actually means male hormone. So the male hormone from the adrenal gland. Most male hormones come from testes. That's why women don't have most male hormones. The majority of male hormones come from testes. But the adrenal gland, the cortex of the adrenal gland, releases a little bit in the adrenal male hormones. So this is just going to supplement sex hormones from the ovaries and testes. In men, this testosterone is actually converted into estrogen. So women have a whole bunch of estrogen from their ovaries and a tiny bit of testosterone from their adrenal gland. Men are opposite. They have a whole bunch of testosterone from their testes. Did I say testes a minute ago? I meant ovaries. I think I said ovaries. Anyway, men have it from their testes, and they have a little bit from their adrenal glands. Good? And make sure you've got supplement sex hormones there. And I wrote in control. So on adrenal androgens, I wrote in controls, blood. Okay, I messed up there. I was looking at the wrong thing. On adrenal androgens, may supplement sex hormones from gonads and stimulate early development of reproductive organs. That should be reproductive organs. Okay, so adrenal cortex. What happens if your adrenal cortex doesn't function right? There's two different things. The first one is Addison's disease. The second one is Cushing syndrome. Now, Addison's disease is where you don't make enough. So, electrolytes and glucose imbalance, dehydration can be fatal if not regulated. Cushing syndrome, that's going to be hyper above, right? So, remember, this is what you really want to know. This is insufficient. Addison's is insufficient. Cushing is hyper above, more. And because of the hypersecretion, you may have tumors or excess secretion of the corticotropic hormone, adrenal corticotropic hormone. That's ACTH. On the Cushing syndrome, highlight buffalo hump down at the bottom. Buffalo hump, that's where they have a humpback, and that's one of the symptoms that's identifiable about a Cushing syndrome patient. Pancreas. You heard that one, right? I know you have. Okay, pancreas is actually the magic gland because it can function as a digestive gland or digestive organ and an endocrine gland. And we'll do digestion later, so don't worry about it now. But it functions, it says endocrine and exocrine. Endocrine gland, it makes hormones. This is your insulin and glucagon that control blood sugar. Exocrine, it actually fits into the small intestines, and it helps digest your food with the small intestines, which we'll talk all about that later. Okay, 3 hormones of the pancreas. Hormones. Digestive juices later. The glucagon comes from alpha cells. Glucagon comes from alpha cells. Beta is insulin, and delta is somatostatin. So 3 hormones: glucagon, insulin, and somatostatin. There it is, cute little orange thing over there on the side. Okay, pancreas, elongated, flattened. It sits just behind the stomach. It sits into the small intestines. This right here is the small intestines. This pink thing right here, that's the small intestines. So this is the pancreas, purple, circled. Okay, you do want to know it does digestive juices into the duodenum. That's that curve is the small intestines. So it fits right into the duodenum of the small intestines. Okay, islets of Langerhans right there. The beta cells are in the islets of Langerhans cells. So, islet of Langerhans cells. So you want to maybe write that in, beta. Right, and beta we know is insulin. Insulin lowers blood glucose. Insulin is like a key, and it attaches to a liver cell and says absorb insulin, absorb sugar. Open up the floodgates, bring the sugar in, get the sugar out of the blood. So insulin lowers blood sugar, while glucagon tells the liver to release sugar, increase blood glucose. Okay, somatostatin, it just says helps to regulate both. It just kind of holds them steady. So besides somatostatin, write in homeostasis. It just kind of helps out insulin and glucagon. Just maintaining it. Okay, diabetes. We know about diabetes mellitus. It's where you don't have enough insulin. It's a lack of insulin. Now, there's type 1, which you're born with. You never made enough insulin. Your pancreas didn't work like it was supposed to. And then there's type 2, which you're diagnosed above the age 20, and that's where your pancreas did work, but your pancreas has stopped working. It doesn't work as well. And so type 1 you're born with, and you are type 1 diabetes, you are insulin dependent. You got to take insulin. So type 2, you can maybe control it with your diet, and hopefully you'll learn a little bit more of this when you do the lab activity. But, so that's diabetes. But you definitely want to know about this. Type 1 is juvenile insulin dependent. Type 2, non-insulin dependent. Maybe you ate too much cake. You abused it. You should have done better. Okay, these glands are important, but they're just not quite as important, so they don't get like a whole slide. You don't get the picture on them. Okay, the pineal gland is in your brain, and it secretes melatonin. You know what that is. That's what helps you sleep. Time to wake up, time to go to bed, no matter what. You can actually take melatonin over the counter. You can buy it at Walmart or Walgreens or whatever to help you sleep at night. Also, something interesting, being out in the sun all day, it makes your brain release melatonin. That's why being out in the sun all day wears you out and you're sleepy at night. Okay, so pineal, melatonin, circadian rhythms. Okay, the thymus gland secretes thymosins. This is going to be immunity. Thymus gland promotes the development of the T cells and its immunity, and that's what the next lecture's on. Is blood cells. And then reproductive organs, of course, we're going to talk about this, but at the end of the course when we do reproduction. Ovaries produce estrogen and progesterone. The testes produce testosterone. And then the placenta, that's what helps feed the baby, right? Produces estrogen, progesterone, and gonadotropin. And so we'll really focus on make sure you got this one for sure highlighted. We'll really focus on the reproductive organs at the end of the course. And next topic, so we're done with the main glands, is stress. What does stress do? Well, my mom always says that stress could kill you, right? So there's two different types of stress. There's physical stress and there's psychological stress, like school, right? You got all this 202 to do, but it's too stressful. But when you're stressing out, it messes up everything. And so stress, it says, survival depends on maintaining homeostasis. So you got to maintain, happy and stressed out for long periods of time. And then really your last slide, and this is how every lecture ends, is what happens when you get old. As you get old and die, what happens to the endocrine system? And this is the things that it mentions. All these glands shrink. And I want you to specifically write in that the thyroid decreases in size. So thyroid decreases in size. And results in reduced immune response. All right, and I hope this was helpful. Be sure to watch this video several times and study hard for your test. This is the first lecture for Test 1.